Hello friends, in this tutorial we'll talk about how to generate a Prufer code for the given tree. We'll also talk about drawing a tree corresponding to the given Prufer sequence. So let's start with the first part. So let's say this particular tree is given. So I have considered, as you can see, vertices from 0 to 7. So total 8 vertices are present and 7 edges. 7 edges are corresponding to line number 230 to line number 236. So definitely this is a tree. So let's verify it by drawing it. So as you can see, this is the tree and we are interested in finding out the unique n-2 length sequence. In this particular case, value of n is 8. So we want 6 length unique code corresponding to this particular tree, which is known as Prufer code or Prufer sequence. So the answer will be stored in the sequence. So let's say the name of the sequence is k and the inbuilt function is to_Prufer_sequence. And the idea of this particular function is we are supposed to pass the name of the tree for which we want the corresponding Prufer sequence. So we will pass t here. So the function will convert this tree into the Prufer sequence. And now the answer is stored in k, and this is the unique sequence corresponding to this particular tree. But now it may be possible that your input tree has vertices from 1 to n in general, not from 0 to n-1. So in that particular case, what you need to do, you need to just add 1 to each and every element of this particular sequence. So this will be your final answer in that particular case if your vertices are from 1 to n. So why I have considered a tree like this where the first vertex is 0 not 1, since the limitation of this particular inbuilt function. This function will take only a tree which has 0 as the initial vertex. So this function will work for tree with vertices 0 to n-1, not for 1 to n. So if you apply this particular function for the tree which doesn't have 0 vertex, then it will give you an error. So this is a two-step process in order to get a correct Prufer sequence for any given tree. Consider the reverse problem. So for the given sequence, now we want to generate the corresponding tree. So let's say the sequence is k and the underlying function is from_Prufer_sequence, and we'll pass the sequence as an argument for this particular function, and we have got the answer. The t1 is the required tree. So let's verify the answer. So this is the corresponding tree for this particular Prufer sequence. But now if you can observe here also the least index is 0, but we want 1 as the least index. So definitely we need some relabeling. So for that I have defined this particular mapping. So what is the idea of this particular mapping? So all the internal vertices will remain as it is. So as you can say, 1 is mapped to 1, 2 is mapped to 2, 3 is mapped to 3. Only change will happen to the leaves. So the idea is the last vertex is 7, but now 7 will be mapped to 8. So as you can see, 7 is mapped to 8. The least vertex is 0, but now we don't want 0. So 0 will be mapped to the nearest leaf. So nearest leaf to 0 is nothing but 4. So 0 is mapped to 4, and now 4 is mapped to 6, and 6 is mapped to 7, and 7 is mapped to 8. So now what we will do, we need to ultimately relabel the tree in order to get the required answer. So for that, the function is this nx.relabel_nodes. So ultimately we want to relabel t1 with this mapping. So our final answer will be stored in w1. So let's verify this. So this is the required tree, and as you can see now labeling is starting from 1 and going up to n. So the main advantages of using these functions are that you can easily verify your answers and that too very quickly, right? Otherwise exactly n minus 2 steps are required if you consider the first problem or the second one. In the both the cases you need to do exactly n minus 2 steps, whereas here you can verify your answer within seconds. Thank you. Subscribe to my channel for more videos.